Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 13 of a unit Work, Power, Energy. Let's begin with today's class. In today's session we are going to discuss about the vertical circular motion. So let's look what vertical circular motion look alike and how does it work. Let's have a look. Let's suppose consider a body having a mass m that has been tied to a string and it is going to whirl in a vertical circle of radius r. So what the situation would be that this is one of the object having mass m has been tied to a string and that object is going to be whirled around this vertical circle in this direction. Yes, so you can look at this that if you observe the different points, point L, point H, that means point M1, this point H or this point M2. First thing would be do all these points having same velocity or different velocity. What it would be? What do you think? Does all these locations having a same velocity or different one? So when I assume this that this is going to be move in this direction and as it is moving in vertical circle, as it is moving on the vertical circle, this has been driven by the gravitational force. Its direction of motion is in the upward direction while the force, that means the acceleration acting on it, is downward direction. Which acceleration? Then we will say acceleration of gravity. So direction of velocity is in the upward direction while the direction of force of gravity is in the downward direction. And as you understand that if direction of motion and direction of force are opposite to each other, its speed is going to be reduced. So m1, I mean to say velocity at m1 would be less than velocity at L as it is going to move further on the upward side and reach at the location H. So again velocity of H would be less than velocity of m1 too. Now from here I am not saying this that at this position velocity equals to 0. No, it would not be. How? We will going to check, but let's just assume that this is not going to be 0 at this position. Now from when it is going to move in this direction from H to M2, now direction of motion, it is in this direction. Direction of force of gravity is in this direction. So direction of motion and direction of force of gravity both are in the same direction. And when this both are in the same direction, I mean the velocity is going keep on increasing. That means I could say this that velocity at m2 would be greater than velocity at h, and same thing is true that velocity at L would be greater than velocity at m2 and something like this. So when we say vertical motion, or I should say vertical circular motion, it is non-uniform circular motion. Yes, have you remember the non-uniform circular motion? Have you? Yes. So at every instance its speed could be changing, then we say it's a non-uniform circular motion. It is the same case here as well. That's why why this is happening, why speed is changing, because it works under the effect of gravity. Gravity will be remain the same throughout the journey, but velocity keeps on changing. I hope this is clear. Is it clear? Is it? Great. Let's look at certain questions. First, vertical circular motion is, yes, uniform circular motion, non-uniform circular motion, rotational motion, non-rotational motion. It's a non-uniform circular motion. Recently we have discussed this. Yes, that when it is keeps on moving on this path, that under the effect of gravity, let's say at this point it would be a speed would be a 30, then this could be 20. This data is being used to understanding purpose only. Yes, this could be 30 meter per second, this could be 20 meter per second, this could be a 10 meter per second, and again this could be a 20 meter per second. So as you can see that, as you can observe that speed keeps on changing, and when it is changing It is the non-uniform circular motion. Great. Next, the velocity of vertical circular motion keeps on changing because of mass of the object. No. Gravitational force? Maybe. Length of the string? No. Tension in the string? No. Yes, it is due to gravitational force. So gravitational force keeps on changing. Due to gravitational force, the velocity of the bob is going to be changed. I hope this is clear. Is it? So now let's look at the mathematical modeling of this vertical circular motion. So we are going to use this. It's an equation for velocity at different positions of vertical circular motion. So let's have a look what would be the situation. Yes, as you can see in the diagram that this is particle P, and on this particle P one of the force is acting, that this is the center through which it has been timed. One of the force that is acting on this particle is tension force, that is acting due to stretch in the string. Yes, this is the tension and it acts towards the center of the body, that we can say that away from the body. Yes, another force is, this is mg. Yes, it's a weight of the bob, and as you can see that if this is vertical reference, then this makes an angle theta with it. So if this is mg, even this would make a theta. So if this would make an theta, it would be an mg cos theta, and this would be the mg sin theta. So the forces acting on the body at position P are, one of the force, it's an mg. Another force, it's a tension in the string. And let's suppose T is the tension in the string, that we understand that suppose it makes at some position P, it makes an angle theta with the vertical diameter that we call as an LO. Now, which are the forces acting? Let's have a look. That we understand that at this position, at position P, centripetal force could be written. Centripetal force could be written as mv square by r. That would be equals to T minus mg cos theta. T would be acting on this direction. Mg cos theta is acting in downward direction. And the difference of this two, it's a difference of T and mg cos theta, will provide me a required centripetal force to move on the circular path. Does it clear? That this is the required centripetal force. It's in T minus mg cos theta. That has been this T minus mg cos theta will provide me the required centripetal force. Does it clear? Does it? Great. So tension at any location could be written like this, that this T is equals to mv square by r plus mg cos theta. While calculating this, and if you remember this, you must take this in mind, that theta has been derived from this position, from OL as a vertical diameter, and from that onwards in an anti-clockwise direction I have considered the theta. Does it clear? Does it? Any doubts up till now? Is there anything? No? Great. So let's look at the value of the tension and value of the velocities at different locations. So first let's begin with at the highest point H. That means when we say it's at top, we can say that TH is equals to mv square by r. I'm talking about the v of h minus of mg. Why this would happen? That look at this. This is th. This is mg. On this direction, it's an mv square by r. So this could be written as th plus mg is equals to mv square by r, and so t at h should be equals to mv square by r minus of mg. Now what happens is, look at this and understood this very carefully, that at this position, there is a chances that string may be slackened at maximum height h. Yes, it is the chances. There is a chances that at this instant string is going to be slackened for that moment only. the tension in the string could be considered as a zero. Why? What do you think behind this? Why the tension could be taken as a zero? Because the string has been slackened. Because the string has been slackened. So I'm just deriving a certain that we call as a critical condition. Yes. So we can say that if if tension at maximum height, if tension at maximum height is equals to 0, at maximum height is equals to 0, then I can write like this: it's an mv square by r minus of mg, that would be equals to 0. And if it has been trying to solve it, it's a vh, that means the velocity at maximum height could be written as root of rg. Have you remember in the very first slide I have written it, that at maximum height velocity is not going to be 0. Look at this, it's a root of rg. I hope this is clear. Is it clear? Does it? Are you sure? Great. So at maximum height at location h, it would be a root of rg. We must understood that therefore the body must reach at the highest point h with minimum speed of root rg in order to remain in circular path. If vh is less than rg, that means we are talking that if it must be reached at the highest point with minimum speed of this, if if this is going to be less than root of rg, if it is less than rg, the string is going to lose and the body falls down and it will not loop the circle. We will call this as a looping the loop, that it will not looping the loop the circle. So at the highest point the string is going to lose and the body will fall down and it is not going to looping the loop. At the lowest point, at this position, at position L, what I could write is this is tension at L, this would be the mv square by r, this would be the mg. So both are acting in the downward direction, so T at L could be written as m into mv square by r plus mg. What I understood is that at this position, tension in the string is maximum at the bottom point, and that's why it is very high probability to break the string, to break the string at lowest position, at lowest position. I hope this is clear. Yes, so it is very high probability because tension is maximum at the bottom and it is minimum, so tension at highest position, this is minimum. I could not say it is always 0 because this is not even possible that always it is going to slacken the string. No, this is not the case, but yes, that is for sure that it would be a minimum at the highest point and it is maximum at the lowest position. Now let's just check and calculate the energy conservation. Through energy conservation, what should be the velocity at VL? So what I'm supposed to do is that I'm going to write that total energy at location L is equals to total low energy at location H. Yes, total energy at the lowest position is equals to total energy at the highest position. While I say total energy, I mean it's a kinetic energy plus potential energy. So this is kinetic energy at L plus potential energy at L. That should be is equals to kinetic energy at H plus potential energy at H. So this would be a half mv square L plus mgh at L equals to half mv square by half mv square H plus mgh. Now if I take this as a reference, let's suppose this is reference, so if I take this as an H is equals to 0, what I am having is that mghl would be a 0. Why? Because height is 0. So this is equals to half mvl square equals to half mvh square plus mg into 2r. How 2r? Look at this. This vertical separation, or I should say vertical displacement, is equals to 2r. So that could be written as half mvl square is equals to mg into 2r plus it's a half into mvl square. If I put the value of vl square, because I know that vh should be equals to root of rg. If we put the value and try to solve this, this will get as the vl should be equals to root of phi rg. So please remember this thing. Please remember this thing, that v at l, velocity at the lowest position, should be minimum would be root phi rg. So this is a very critical point. Please do remember this, that for looping the loop, velocity at L should be greater than or equal to root of phi rg. So minimum velocity required would be phi rg, I mean under root phi rg, and if velocity is greater than that, it is well enough. Yes, while I say looping the loop, for looping the loop, that means to complete at least one vertical circle. So when we say that whether this will looping the loop or not, then I am always meaning that I always mean it that at the lowest position, its velocity should be root of phi rg. If its velocity is greater than that, then it is well enough. But if it is less than this, it is not going to looping the loop, and it is going to loosen, it is going to lose the path of its vertical circle. Great. So now the situation is, we know the velocity at this position. Now let's just find it out. Velocity at this location vm1, because we know this is root phi rg. We know this as a root of rg. Now it's a turn for m1. So what I need to do is, at every time when I require a velocity, I'm going to write down the total energy. Yes, it's an energy conservation. So what I can do is, it's a total energy at L point would be equals to total energy at M1. While I say total energy at L, I mean it's a kinetic energy at L plus potential energy at L. That should be is equals to kinetic energy at M1 plus potential energy at M1. While I'm writing so, it's an half mvl square plus mghl is equals to half mv square at m1 plus mgh at m1. We have taken this as a reference, and when I have just taken this as a reference, this should be an h is equals to 0. So this is equals to mgh would be converted to 0, and that could be written as half mvl square plus 0. That would be equals to half mv square at m1 plus this is the location, this is the separation, is r plus mgr. If I put vl should be is equals to root of phi rg, if I put vl should be is equals to root phi rg, let's just replace the value. If you are going to replace the value, then velocity at m1 would be equals to root of 3 rg. So this is the velocity at this location, it would be a root of 3 rg. I hope this is clear. Is it clear? Do you understand each thing, everything? Are you clear? Are you clear with it, conceptually as well as data wise? Yes? Great. Let's look at certain questions. It says that in vertical circular motion, the tension in the string is maximum at, yes, the situation is something like this. Yes, this was, let me read through this. Yes, so from here I have made an angle theta. This is the location where tension is maximum. So this is T, this is mv square by r, this is equals to mc. So it's a theta is equals to 0 degree. It's a theta is equals to 0 degree when tension is maximum. Does it clear? Does it? Great. It says that the minimum speed with which the particle must reach the highest point in order to remain in circular path. Yes, it would be a root of rg. We have derived this. Yes, that at this position its speed should be minimum root phi rg, or even I could say so that at lowest position its speed should be root of phi rg. If if it is if it is there, then and then only it can reach, then and then only it can remain in the vertical circle. Otherwise it is not possible to remain in the vertical circle. I hope this is clear. Great. Next question. In vertical circular motion, the velocity at the highest position is given by, again same question, it's a root of rg. If they says that the velocity at lowest point is given by, where it would be velocity at lowest point, yes, it is at root of phi rg. I hope this is clear. Is it clear? Got it? Great. Now let's discuss the energies in vertical circular motion. Let's have a look. Let's suppose when what we consider is that, let's suppose body is at location at L, and when the body is in vertical circular motion at bottom, when we say at the lowest point, its velocity is VL is equals to root of phi rg. So at this location, what I understand, kinetic energy, this would be equals to half into m into v square. If I replace the value of VL, that is of root phi rg, then the kinetic energy at this location would be equals to phi by 2 mrg. And at this position, because I have considered this as a reference, so I took this as an h is equals to 0. So at this location potential energy would be 0, and while potential energy would be 0, this would be the 0. So kinetic energy would be equals to phi by 2 mrg, and thus the total energy, that is the addition of potential energy plus kinetic energy, it would be equals to phi by 2 mrg. So this is the total energy. This is the total energy at lowest position. Yes. Now let's just calculate. The body reaches to here, it's a highest position, we call it as a VH. So when the body is in vertical circular motion and it is about to reach at the top highest position, this VH would be equals to root of rg. And if I calculate the kinetic energy over here, it's a half mv square, and while I write VH square, it's a VH is equals to root of rg, so this would be equals to mgr by 2. And the potential energy at the maximum position, it's an mg, this is 2r. So total energy would be equals to potential energy plus kinetic energy. This would be mg 2r plus half mgr, that would be 5 by 2 mgr. Yes, so total energy at the least position is equals to total energy at the highest position, though that means total energy in vertical circular motion is conserved. While I say total energy in the vertical circular motion is going to be conserved, that means you can have addition of potential energy plus kinetic energy at any of the location same, but I'm talking about the potential energy plus kinetic energy. Yes, great. So when the body moves from the bottom to top, kinetic energy gets converted to potential energy, and when it moves from the top to bottom, potential energy gets converted to kinetic energy. Does it clear? Does it? Are you sure? Great. So what we understand is that total energy in vertical circular motion is always going to conserve. Next, potential energy. Potential energy at lowest position is, we cannot say always 0. No, this is absolutely incorrect. It is minimum. Yes, so you are not going to, let's suppose this is the lowest position, and this is going to move in this path. Yes. So if you have taken this as a h equals to 0, this will be a 0. But this is not always the case, because sometime you are assumed to take h is equals to 0 over here. So at this position, potential energy would be equals to minimum. At this position, potential energy should be minimum. It should not be taken as an h is equals to 0 at every time. So, so in this situation, this is the correct answer. I hope this is clear. Is it? Is it clear? Great. It says total energy at the highest point. Total energy is always 5 by 2 mgr. Yes, total energy at the highest point is 5 by 2 mgr. We have derived it. Yes, it's basically the addition of potential energy plus kinetic energy. Does it clear? Does it? So now I am interested in the velocity at any point in the vertical circular motion. So let's just check how I'm supposed to do this. Let's have a look, because this is important and this is required, that if I want to find out the velocity at any of the location, I must be able to write down this. So let's just check that the equation for velocity at any point in the vertical circular motion. What I'm supposed to do is I will write that total energy at L should be equals to total energy at location P. While I say total energy at L, I should say it's in half mvl square plus mgh at location L should be equals to half mv1 square, or I should say it's a v, half mv square plus mgh. Now at this location, let's I have assumed h is equals to 0. So this is going to be converted to 0. Now how should I write this h? How should I write this h? So if you observe this very carefully, the situation is something like this. Yes, this is theta, this is r. So this is r cos theta, this is r sin theta, and I am interested in this. Yes, talking about this point, and this is r as a total. So when I write h, I should write it as an r minus of r cos theta, and while doing so, it's a r into bracket 1 minus cos theta. So my h should be is equals to r into bracket 1 minus cos theta. Now if I replace this VL with the V1 and put up the value, and if try to solve this, then I am having the velocity as such as, look at like this. It should be a root of V1 square minus of 2gr into bracket 1 minus cos theta. I hope this is clear. Is it clear? Is it? Are you sure? So this is the formula, or this is, we can say, the equation which can give us the velocity at any of the desired location. Yes, you just need to put up the value of theta and get your answer done. Does it clear? Does it? Are you sure? Great. Now let's just check out. Let's just calculate the difference in the tensions at the lowest position and highest position in a vertical circular motion. So when I say at point H, velocity at the highest position should be equals to root of rg, and at this location tension would be in the downward direction, mg would be in the downward direction, and mv square by r would be in this position. So tension at the highest point would be equals to mv square by r minus of mg, and if I replace the value of the vh, that is root of rg, then I will get tension at the highest position. This is equals to 0. This is called as when I say th is equals to 0, this is what we call as a critical condition. So sometimes they will not going to say that tension at highest position is zero. But what they are supposed to say is that if critical condition is satisfied, find out this and that. So when they say if critical condition is satisfied, what they actually saying is that TH, this is the first thing they are indicating, that first TH, tension at maximum height, is 0. Second thing, velocity at maximum height would be equals to root of rg. And third thing, velocity at the lowest point is equals to root of phi rg. This all are the minimum I am talking about. That velocity at height h minimum would be root of rg. Velocity at the lowest position would be equals to root of phi rg. So this is what we say about the critical condition. So they just say that critical condition is satisfied. That means I can take all these things. Yes. One more thing. This is the first approach. Even they can say that object is looping the loop. So when they say object is looping the loop, even all this three could be considered. I hope this is clear. Is it? Is it clear? So these are the indirect approach to asking questions. I hope this is clear. Is it? Great. Let's just check out the difference in the tensions we were calculating this. So we have already calculated the tension at the highest point, and uh, that I calculate as a 0. Now let's just calculate the tension at the lowest position. So when I calculate the tension at the lowest position, this is T at L, tension would be over here, mv square by r over here, and it would be a plus mg. So T is equals to mv square by r plus mg. If I replace the value of the v at L, it's a velocity at the least position, at the lowest position. That was we have derived, it's a root of phi rg. If it was the case, the tension at lowest position would be equals to 6 mg. So here you have received the tension is 6 mg. Here the tension was 0. So difference of this will be always 6 mg. Even this is not satisfied, even if it is the case that the string has not been slackened at height h. Even though tension, I should say a difference of the tensions would be 6 mg for sure, each time, every time. Does it clear? Does it? Are you sure? Great. Now let's just check the certain questions. It says that in vertical circular motion, difference in tension at the lowest and highest position, yes, it is the 6 mg. It is the case as always. Next, in vertical circular motion, tension at highest position. Tension at highest position is highest, and tension at highest position would be the lowest. My mistake. Yes. So situation is something like this. This is the T1. This is the T2. So this T1 would be the lowest, and tension at this point, it says tension at this point T2 is highest. Yes. Does it clear up till now? Does it clear everything? Are you sure? Great. So let's just summarize all the situations that we have discussed up till now. So let's begin with this. It's a summary of the vertical circular motion. So when I say vertical circular motion, the situation would be something like this, that this is the string. Bob is there having mass m. It has been attached over here, and it is going to move in this kind of vertical circle. So this is the lowest position. This we can say as the highest position. Let's suppose this is at a location, certain location, and this is angle theta. So what we can say is, first, for looping the loop, velocity at the lowest position should be greater or equal to root of phi rg. First thing, for looping the loop, while I say looping the loop, I mean it is to complete at least one vertical circle, the velocity at the lowest position should be greater or equal to root of phi rg. This is required. The second thing is when velocity at bottom point, at bottom position, is root phi rg, tension at highest position, tension at highest position will be 0. Yes, that we know, but if velocity at the lowest position is root of phi rg, then tension at highest position, then tension at the highest position will not be 0. Yes, we must keep this in mind, that it is not the always case that tension at the highest position would be 0. No, tension at highest point could be 0, could be, if velocity is root of phi rg, if velocity at the location L, it's the lowest position, is root greater than root phi rg, then tension at the highest point will not be 0. Yes. Next the situation would be, let me draw this and then we will discuss this. If this is the location theta, this is t. So to find out tension at any position p, what do you need to do? Tell me. To find out the tension at any position p, what I understood is that this would be the t, this would be the mg, this would be the mg cos theta, and this will be the mv square by r. So t at any location p would be equals to mg cos theta t at any location would be equals to, or I should say it's a t minus mg cos theta, that should be is equals to mv square by r. That should be t at p should be equals to mg cos theta plus mv square by r. Yes. Now this is the velocity at point p. Again, this is the velocity at point p. And one more thing, to find out velocity at any point p, to find out a velocity at any point p, use energy conservation. Yes, this is the lowest point and this is the point p. So you can say this, that total energy at L is equals to total energy at p. Yes, and you can do the rest of the things. I hope this is clear. Is it clear? Is it clear up till now? Any doubts? Any doubts? Is it there? Is it there? Are you sure? Now, one more thing. In fact, two more points to discuss, and you are going to remember this. That let's suppose this is the circular trajectory. Let me redraw. This would be the circular path on which it is moving. This is lowest position. This is the highest position. Let's suppose this as an m1 and this as an m2. So the case is that if velocity at the lowest position is less than root 5 gr, but VL is greater than root of 2 gr, particle will leave the circle. Particle will leave the circle from M1 to H somewhere. From M1 to H somewhere. That means first thing, first thing is, if VL is root 5 gr, does it complete the looping the loop? Can it complete the one vertical circle? No. So where does it leaving the circle? That means we can say it's in from M1 to H, from somewhere in between of this it is going to leave the trajectory. I hope this is clear. Now one more case, if velocity at the least position is less than root of 2 gr, if it is less than root of 2 gr, then Bob will oscillate, then it will oscillate from M1 to M2. Yes, something like this, from here somewhere. Yes, I hope this is clear. Is it clear? Is it? So will you be capable to do the questions, all these questions? Will you be? Are you clear? Are you clear? While I say it will oscillate from M1 to M2, then we can say that it will oscillate about position L. Yes. So L will work as a mean position. What mean position? That we will understood while talking about the SHMs. But you just remember this position, that if it is less than root 2 gr, it will going to oscillate at somewhere here. I hope this is clear. So are you ready for the questions? Are you? Let's have a look. Let's suppose this is the trajectory, and let's assume that this is the reference line. This is the location R. This is height h, which is equals to, let's say, 4r. And we have one object over here. So this is initially, this is at rest. So the question is, will the object can looping the loop? This is question. Will the object can looping the loop? This is the question. So what you understand, how will I decide? What I understood is for looping the loop, this is least, this is highest. Velocity at L should be less than or equals to root of 5 gr. Yes, minimum velocity would be root 5 gr, and if it would be greater than this, it would be, well, good enough. So for looping the loop, velocity at the least position should be less than or equals to root of 5 gr. I hope this is clear. Is it clear? Now let's just check it, that let's give this location a name of A. So what I can write is, it's a total energy at A should be equals to total energy at L. While I say total energy at A, it's a potential energy at A plus kinetic energy at A should be equals to potential energy at L plus kinetic energy at L. So potential energy at A, this is H is equals to 4R. Let's say its mass is M. So potential energy at, it's an mgh, plus kinetic energy at A, it is at rest. So this will be 0. That should be equals to potential energy at this. This is considered as an H is equals to 0. So this is 0. So this would be half mvl square. While doing so, it's an mgh should be equals to half mvl square. This m has gone. and while this has been gone, it's a VL square. That should be equals to root of 2 into G into H. If I write H is equals to 4R, it should be equals to 2 into G into 4R. That should be root of 8GR. This is VL. Yes, is it clear? Is it clear? So VL is root 8GR, and while I say VL is equals to root 8GR, I mean my velocity is greater than what required, because only the velocity required is root 5GR. So when I say this, that when this was the situation and this H is equals to 4R, the velocity at this position V at L is equals to root of 8GR. So I mean particle will looping the loop, because particle is having velocity at L equals to root of 8GR, which is greater than the root of 5GR. A first thing has been done. Now let me add the question and you just answer it. So let's suppose this is the location, I name it as a 1. So question is, find out velocity at 1. So what you need to do is, this is 90 degree that you can observe. So what I'm supposed to do is, it's a total energy at L would be equals to total energy at 1. And while I say total energy, I mean it's a potential energy at L plus kinetic energy at L should be equals to potential energy at 1 plus kinetic energy at 1. If potential energy at L, this is assumed as a 0, so this is 0 plus kinetic energy, it's a half into m into VL square, which is 8GR. This is equals to potential energy at 1. This is angle theta, which is 90 degrees, so this is mgr plus kinetic energy, that is what I'm looking for. It's in half mv1 square. So this is 2, this is 4 mgr, so this would be if you observe this is 4 mgr, this is mgr, so this is 4 mgr minus of mgr should be equals to half into m into v1 square. So this is 3 mgr should be equals to half into m into v1 square. This mm has gone, and this v1 square should be equals to 3 2s v1 square, or I should say v1 is equals to root of 6gr. So this was the situation. That this was h is equals to 4r. At this location, velocity would be root of 8gr. Now at this location, it is root of 6gr. Now again I want to add one thing. This, let's say this is the highest position. Yes, find velocity at th, or I should say find velocity at highest location. So how will you do it? What I need to do is that the total energy at least position is equals to total energy at the highest position. Now here it's an mgh plus half mv square, it's an 8gr, should be equals to, look at this, if this is the r, even this would be the r. I hope this is clear. So it's a potential energy is mg2r plus half mvh square. As at this point h is equals to 0, so this is going to be 0. This is 4 mgr. Yes, so this is 4 mgr equals to 2 mgr plus half mvh square. So this would be equals to 4 mgr minus of 2 mgr. That should be equals to half into m into vh square. So this is 4 minus 2, it's a 2 mgr. That should be equals to half into m into vh square. This mass could gone, and vh should be 2 2s are 4, it's a 4 gr. I hope this is clear. Is it clear? Is it? Great. Now shall I add one more thing? Let's have a look. The question says that in the previous question, find out normal force acting at the highest position. This is required. We need to find out the normal force acting at the highest position. The situation was something like this. This was the this was the situation at th, and this th at this highest position, I should say this is at the highest position. The velocity at highest position what root of 4 gr, and object will be something like this. Yes, because it is moving in this trajectory. So now what do you want? You want the normal force. How will you do this? What can be done? Let's have a diagram. This is the normal, this should be the mg, and this should be the mv square by r, I should say mvh square. So it's an n plus mg should be is equals to m into vh square divided by r. So this is n plus mg is equals to mvh square by r. This should be written as n is equals to m by r into vh square. This is equals to 4 gr minus of mg. So this has gone, it's a 4 mg minus mg, it's a 3 mg. I hope this is clear. So do you understand the complete situation? Did you understand this? Are you sure? So will you be capable enough to do this? Will you be capable enough? Are you sure? Can we do it? Can we? Great. So now are you ready for the next question? Will you be ready to for the next question? I hope yes. Let's have a look to the next question. Always consider that at the least position velocity required would be root of 5 gr, that is the minimum velocity required. Yes, and then you need to go for the energy conservation and the things will be done. Yes. Now let's move to the next question. Suppose the situation is something like this. Let's say a spring is there, and here one of the block is there, let's say mass m, and this is the radius r of this circle. The spring is k. So the question says that find out compression of the spring is required so that when block detached from the spring can looping the loop. So in reality the situation is that it is something like this. this two have not been connected, that means these two are not going to be attached. What we are supposed to do is that I'm going to compress the spring over here with this, with the help of block obviously. So when I'm going to compress this, and when I just release it, I need to find out the compression of the spring so that this block should looping the loop. So what I understood is that work done on the spring should be is equals to kinetic energy at the lowest position. I hope this is clear. So minimum kinetic energy at lowest position required is it's an half mvl square, and that vl would be the phi gr. So this is minimum required. What I'm supposed to do is work done due to spring, or work done on the spring, sorry, it's an half kx square. Yes, because initially it has been unstretched. So now it's an half kx square should be is equals to phi by 2 mgr. If this 2 has gone, x should be root of phi mgr divided by k. Yes, this is the minimum compression required. This is the minimum compression required such that this block can looping the loop. I hope this is clear. If 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 compression is greater than this, if compression is greater than this, yes, then it will definitely looping the loop. Did you got this? Did you get this? Are you sure? So can you do this? Will it be possible for you guys? Are you sure? Great. Now I hope this is clear up till now. Is it clear? Are you sure? Are you sure? Great. Let's work for the next question. Suppose the situation is, let's suppose, if you remember the class of the collision, we have this pendulum that we call as a ballistic pendulum. This is mass m. Initially it is at rest. This is the length L. Yes, this is the length of the pendulum. We have one bullet having mass m and velocity u. So the question is, find out velocity u of the bullet so that bullet plus mass m can looping the loop in a circle of radius L. So what you need to do is that the situation would be, this is mass m, this is u, it is going to hit this, and when it is going to hit this, this is going to be embedded in this, and when it is going to be embedded in this, it is will be having a loop circular motion, and that circular motion would be such that it can looping the loop. So how will you do this? First, what you need to do is that you need to find out the velocity of both this at this position. So at this position, what I can conserve is that this is initial potential, initial momentum. It's a pi is equals to p final. Initial momentum is equals to final momentum. So while I say initial momentum, it is m into u plus m into, as this is at rest, this would be 0. Now at this position they are going to embed, and when they are supposed to embed, it's a m plus m into v. So this is mu is equals to m plus m into v, and this v is equals to m into u divided by m plus m. Now for looping the loop, v at the lowest, minimum equals to root of phi gr, or I should say v should be L should be greater than or equals to root of phi gr. Now what is my velocity at the minimum position, at the lowest position? It is m into u divided by m plus m should be greater than or equals to root of phi gr. So while I'm working for u, it's the initial velocity that I'm looking forward. So u should be greater than or equals to m plus m divided by m multiplied by root of phi gr. I hope this is clear. So this is the minimum initial velocity required of the bullet, so that this both as a combined system can have a vertical circular motion. Does it clear? Are you sure? So do you understand this thing completely? Any doubts in this? Is there anything? Is there? Are you sure? Can you do this? Can you? Will you be capable enough to do this? Are you sure? Great. So, ready for the next question? Ready? Let's have a look. The question says that let's suppose this is the pendulum, and this is the, let's say, radius r. This is the highest position, and when they say that this is the highest position, again this is the radius r, and it is going to move like this on this trajectory. Yes. So if it says that if tension at the highest position, if tension at the highest position is th, and at lowest position is TL, find out difference of TL minus T at, let's suppose this is M1, that's T1, when critical condition is observed. This is the requirement, that find out difference of the TL minus TM when critical condition is observed. So what I can write when they say when critical condition is observed, what should we write? So when they says that critical condition is observed, that means they want that velocity at the lowest position, this is lowest position, this is highest, velocity at lowest position would be equals to root of phi rg. I hope this is clear. So this is the situation where velocity would be equals to root of phi rg. I hope this is clear. Is it clear? Now the situation is at this position, this is t, this is mg, and this would be the mv square by r. In this situation, this is the tension at the least position, this is the tension at the m1 position, this would be the mg, while this would be the mv square divided by r. So let's just calculate the TL over here, and then we will think what to do. It's a TL, it is the situation. Yes, this was the TL, this was the mg, this was the mv square by r. So this TL should be is equals to mg plus mv square by r. This is equals to mg plus m by r into v square. It's a phi rg. Yes, this is the minimum condition. This 2 has gone, and this would be the 6 mg. Now this is the position m1. So what you need to do is, first you need to calculate a velocity at this position. So it's a total energy at the least position is equals to total energy at the m1. So while I say total energy at the least position, this is potential energy, which is mg0, plus kinetic energy. It's a half into m into v square, which is phi rg. That is equals to total energy at m1. It's a potential energy, which is mgr, because this is vertically displaced by r distance, plus kinetic energy, which should be an half mv m1 square. So if I solve this, it's 5 by 2 mgr should be equals to mgr plus half mv at m1 square. While I doing this, this is 5 by 2 mgr minus of mgr should be equals to half into m into vm square. It's a vm1, yes. So it's a 5 minus 2, which is 3 by 2 mgr should be equals to half into m into vm1 square. So this has gone, this is gone, so vm1 should be root of 3gr. Now at this position, so tension at m1 position should be equals to, as we have observed in the last slide as well, it's a tension. This is m, I should write this is mv square by r. So this is m into vm1 square divided by r. This is equals to m by r multiplied by 3gr. This is, so this is tension at m1, which is 3 mg. So the difference is tension at lowest position minus tension at m1. This is 6 mg minus of 3 mg, and this would be equals to 3 mg. This is the difference, TL minus TM1. I hope this is clear. Is it clear? Is it any doubts up till now? Is there anything? Is there anything? No? Will it be clear? Are you sure? Great. Let's look at this question. So before proceed for this question, let's understand the situation. The situation is, let's suppose this is a sphere, and let's suppose this is the center of the sphere, and let's say this is radius r. Yes, an object, that means a ball is there. Initially this is at rest. So what they are supposed to ask is that if ball is released from rest as shown in figure, find out angular displacement theta at which ball will leave the circular trajectory. Yes, this was the question. Initially this was at rest, and they asked that what would be this at what angle, again with the vertical, that at what angle this ball is going to leave the circular trajectory. So this is the question. How will you do this? First understand what the situation will be, that it is moving in this direction, and let's suppose this is the situation, this is the angle. So if I draw a reference line, this is the reference, again this is the radius r, this is the angle theta at which it is going to leave the trajectory. I hope this is clear. Is it clear? So now let's just understood what we are supposed to do is, let's draw the half of the circle, that's probably that helps to understand the concept more clearly. Yes, object was over here, and when it was about to reach here, it is going to leave the trajectory. So this is the angle theta. Now what all forces are acting, that initially the normal was acting over here. Yes, mv square by r again over here, and now I understand that this is mg cos theta over here. I hope this is clear. Yes, one more thing. When ball will leave the circular trajectory, its normal force, and would be equals to 0. Why? Because when and when it is going to leave this trajectory, it is not in contact with this circle. Yes, and when you are not in contact, if you are not in contact, normal force would not be acting on you. I hope this is clear. So as normal force is not going to act on you, what you can write is that the initially the situation was n plus mv square by r should be is equals to mg cos theta. Now as a normal force is equals to 0, you should write it's an mv square by r should be is equals to mg cos theta, and this has gone. So this is v square, should be equals to rg cos theta. I hope this is clear. This is v square is equals to rg cos theta. Let's understood that this is a relation number 1. Now the situation is this was our situation. In fact, it is a circle in manner. We are making it with the half of the circle so that things look easier. Now let's just assume that this is the location 1 and this is the reference. That means this is height equals to 0, and this is the location number 2. This is h. So if I write total energy at location 1 is equals to total energy at location 2, this is potential energy at 1 plus kinetic energy at 1. That should be equals to potential energy at 2 plus kinetic energy at 2. As this has taken as a reference, its potential energy is 0. It was at rest initially. So again this is 0 is equals to potential energy. Now what is this? It would be minus of mgh. Why minus? Because we are moving in the downward direction. Plus kinetic energy. The energy, it's a half mv square. Now so this is half mv square. Is equals to mgh. While how could I replace the h? That h would be equals to r into bracket 1 minus of cos theta. So if I replace this has gone, and v square equals to 2 into g into h, while h is the r into bracket 1 minus cos theta. This is v square. I hope this is clear. This is relation number 2. So initial relation was saying this, that v square is equals to r g cos theta. This was our first relation. Now this is the second relation. Let's just compare this, both the v square. Let's just try to compare it and let's see what happens. This is rg cos theta should be is equals to 2 into g into r into bracket 1 minus cos theta. So this is equals to 2gr minus of 2gr cos theta. This is equals to g into r into cos theta. So this is 3gr cos theta should be equals to 2gr. This gr could be gone, and this cos theta is equals to 2 by 3. So this theta is equals to cos inverse of 2 by 3, where it is going to leave the trajectory something like this. something like this. Yes, this is theta. I hope this is clear. So this cos theta would be equals to 2 by 3 when it is going to leave the trajectory. I hope this is clear. Is it clear? Is it? Is it clear? Are you sure? Great. Now, if I add something, if I want to add something, let's have a look. That question says that in the previous question. Find out vertical and horizontal displacement of ball when it has left the trajectory. So let's just draw this, that this was the situation. We have a circle over here, and when we say that this is the circle, this was the center, this was the radius r. When it was at here, this is the angle theta at which it has left the trajectory. So again, this is r. What do you need? You need a horizontal displacement, something like this, as well as you need this vertical displacement. So let's write down this vertical displacement as a y, this vertical displacement as an x. So the situation is, let me redraw this as this is theta and this complete as an r. This would be the r cos theta, this would be the r sin theta. So h, that is the vertical displacement, it is the r into bracket 1 minus cos theta, and the x as the horizontal displacement, it is r into sin theta. So let's just calculate the h, which is equals to r into bracket 1 minus cos theta. Cos theta, it's a 2 by 3. That should be equals to r into 3 minus 2, it's a 1 by 3. It's an r by 3 from the top. This is the vertical displacement from the top. If you want it from bottom, then you need to calculate it from here, but that can be done. Next, x is equals to r into sin theta. Now what is the value of sin theta? Because I know that cos theta is 2 by 3. Let's just have this. This was the situation. This is theta. If this is theta, cos theta is 2 by 3. So this is 2, this is 3. What it would be? So let's just assume that this is, let's suppose n. So this is 4, 2 square plus n square is equals to 9. So n square is equals to 9 minus 4, it's a 5. So n is equals to root of 5. So from this, x is equals to r sin theta. This is equals to r into sin theta. From this, sin theta is root of 5 by 3. So this is the horizontal displacement. This is the horizontal displacement that it has traveled. I hope this is clear. Is it clear? Have you got this? Did you? So will you understand this very clearly? Very clearly. Are you sure? Great. Now let's finally look at the certain special cases of vertical circular motion. Let's suppose case number 1, that a rigid iron rod has been attached with bob of mass m. Find V minimum at lowest position. Find out V minimum at lowest position so that it can have looping the loop. So now the situation is, initially when we used to deal with this, it was just the string, and when it was string, let me show you that the situation was something like this, that it was moving like this and come back to here. So when it reaches to here, there are chances that at this point, at the highest position, string would be slackened, and as string would be slackened, the tension would be zero, and we are going to derive the everything. But now in this situation, this is a iron rod. So when I say iron rod, when it reaches to maximum height, when this will reaches to maximum height, there are no chances that it is going to be slackened down. I hope this is clear. And if it is not going to slacken down, if it is not going to slacken, the situation is that it is at highest position, tension will not be equals to zero. So what you need to do is, you just need to understood that this is your first location, this is your second location, and what you need to do is, it's a total energy at 1 should be equals to total energy at 2. Even if velocity at this position is 0, as it is an iron rod, this will continue its trajectory. So what you need to do is, let's suppose this is h equals to 0. So it's a potential energy at 1 plus kinetic energy at 1, that should be equals to potential energy at 2 plus kinetic energy at 2. Potential energy of 1, it's an mg at 0. Kinetic energy, it's an half mvl square. This is potential energy at 2, this is mgh, and h would be equals to 2r plus kinetic energy, we can say it's a 0. So this mass could con, and this vl should be equals to root of 4gr. Yes, it is surprising, but it is fact that when this kind of situation is there, when a rigid iron rod is there, and while I say rigid iron rod, what I mean is that there are no chances that even if the velocity at maximum height is 0, that then it will leave the trajectory. If you have certain arrangement like this, that at maximum height its velocity, even though it is 0, it will not leave the trajectory, then velocity at the lowest position will require only root 4gr, not the root 5gr. I hope this is clear. Even one more case of similar situations could be there. Let me show you. Let's assume one circle is there, and you have certain kind of tube like thing, something like this, and your object is going to move in this path. Yes, something like this. This is the circle R. So even in this situation, V at least could be root of 4gr. This can possible that maximum height at 0, but it is not going to leave the trajectory. So these two are the minimum, or we can these two are the special cases of vertical circular motion, in which if velocity at least position, at lowest position is root 4gr, it will continue to move in its vertical circle, and it is not going to leave the trajectory. I hope you got this. Are you clear? Are you clear with this? Are you sure? Great. So let's just wind it up this session over here. This is all about vertical circle. Yes, please go through it. This is very important topic as far as work power energy is concerned. Please revise this. Thank you. Have a good day. Take care. Bye bye.